Okay, for this video, we'll be going through waves, transverse waves specifically. Success criteria B, which is to show an understanding that waves transfer energy, okay, without transferring matter. Now, when a wave propagates or moves out of its source, alright, the source of vibration, the medium's particles do not get transmitted out. Instead, they just vibrate about their rest position. So the energy of the wave is transmitted by these vibrations away from the source. For transverse wave, to know the directions that the medium's particles are moving in, okay, so this is a typo, we construct the next wave that will be produced at the next instance. Okay, so first step, we need to draw the next wave. Okay, how do we know the wave direction? Usually the question will give. So in this case, the direction of propagation is from the left to the right. So I will need to draw the next wave slightly on the right of the original. So in this example, the next wave is actually drawn as a dotted line. Okay, so this is the first step. So question is, will the wave always be moving from left to right? It depends on the question. Sometimes it may go from right to left, or it can go from left to right. So the question will specify left to right. Okay, so after you have drawn the next wave, just slightly to the left, to the right of it. Okay, so example, do not do this. If this is the original wave, you do not draw the next wave looking like this. Let's say this is the next wave. Okay, so just draw something that is close to it, close to the original wave. Maybe like this. Just shift it slightly. Okay, so this is what we mean by drawing the next wave. Next, if we are talking about this particle that is on the crest, we know for certain, because the crest is the maximum height, maximum displacement, okay, we know for certain this particle is going to be going down. Similarly for this particle as well, and this particle. Okay, but for the wave, for the particles at the trough, which is the lowest point, we know for certain that it will be moving up. Okay, remember this is transverse wave. For transverse wave, what comes to mind is that the particles are vibrating perpendicular to the wave direction. So if the wave is going from left to right in this case, the particles will be moving up and down because we are talking about transverse. Okay, so the particles will be moving up or down, right? To form a direction, they will be moving in a direction that is perpendicular to the wave direction. Okay, so the wave is going from left to right, the particles will either be moving up or down. And going back to the crest and trough, the particles at the crest and trough position, we know for certain that they are going to be moving either up or down, right? Once you're at the maximum height, you will certainly go down. Once you're at the lowest point, the next direction that you will be moving will be up. But what about all these particles that are in the center, or even this? Okay, or even this one. How about this? Okay, so after drawing the next wave, the next step that you do is draw vertical line using your ruler at the particle position, at the particle's position. So we want to know about this particle, so we draw a vertical line. Okay, we draw a vertical line, and after you draw the vertical line, you'll find that the intersection with the next wave, the one that's dotted, will tell you its subsequent position. So in this case, this particle will be going up. So if I were to draw a vertical line, this vertical line is for this dotted for this particle, and it cuts the dotted line, which is the next wave, over here. So we know it is going down. So this will be going up. This okay. How about this? If we draw a vertical line, it cuts over here, it will be going down. Just now we say this particle, right? It is not at the rest position. It is just somewhere in between the rest position and the crest. We draw a vertical line. Similarly, we know it cuts here, so it will be going down. So with this, we will know the direction of the particle in the subsequent motion. Okay, so you can try for this next example, whereby we have the wave going from right to left. Okay, right to left, and you see that the next wave is drawn to the left of the original. So this is the original. This is the next wave. Okay, so this has been drawn for your. Next, you just need to apply this. Draw the vertical line and you'll be able to determine. Okay, why do we need to learn this for this kind of question? Okay, B1, the diagram below shows the profile of a part of a wave moving from left to right, so we know the direction of the wave. On a piece of string, P, Q, R, and S represent various points along the piece of string. Okay, so first step, we draw the next wave. Okay, so with a dotted line, I draw slightly to the right of it, because the next the wave direction is to the right. Okay, so once I've drawn this, step 2, I need to draw a vertical line. Okay, since there are 4 points, P, Q, R, S, let me draw the vertical line. So we know that P will be moving up, right? Because this is original, this is where it cuts, so it's moving up. So how about Q? Again, draw a vertical line. So this is the original, as shown now. On the next wave, it is being cut over here. So I know Q is going down. For R, it is also going down. For S, it is going down. Okay, so if you were to ask me, if I don't do these 2 steps, will I be able to tell whether the particle is going up or down? I can't. I can only tell you about the crest and the trough. Okay, so please learn this method. Okay, unless you have a better method, please let me know. Okay, so they say P is permanently at rest. Now, this is our P. P is at the rest position. P is at the rest position. So a lot of people will say, oh, if it's at the rest position, shouldn't the speed be equals to 0? That is incorrect, because the speed is actually maximum. Remember, where do we have 0 speed? The crest, we have V equals to 0, the speed is 0, because it's already at the highest point. Okay, so it has already stopped. Another position is at the trough. So all those points or all those particles at the crest and trough, their speed will be 0. Okay, so P is permanently at rest. That is incorrect. How about S? Is S moving upwards? No. Based on these 2 steps, S is actually going downwards. How about Q? Q is moving downwards? Yes. P and R are moving in the same direction. P is going up, R is going down. Okay, so answer is C. Now B2, a wave is set on a rope such that it travels in a direction shown. So I purposely draw the wave direction from right to left. So now let's practice drawing next wave. Okay, something like that. A rough sketch will do. Just takes a little bit of practice. Okay, what happens to wave particle Q at the next instant? So step 1, we already drawn the next wave, is going from right to left, the dotted line. Okay, now Q is here. Draw a vertical line. Where does it cut? It cuts the top, right? It cuts the top. That means the next instance is going to be somewhere there. So it's going from, at the rest position, is going up. So it will move up. Now, a common misconception is that you'll move to the left or you'll move to the right, which is not correct. If it's moving to the left, moving to the right, it becomes parallel to the direction of the wave, right? So no, because we are talking about a rope wave, and rope wave in this case, they show the profile of a transverse wave. Okay, so this is for your success criteria D. We'll be using this skill later on.